Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for October-November 2023, variant 2. So let's get started. Question 1 says which quantity is a scalar quantity? So acceleration, force have direction, velocity also has direction, time does not have direction. So the answer is C. Question 2 says a student measures the average speed of a cyclist in a race. Which quantities must she measure? So the total time taken to complete the race and the time taken for the cyclist to reach high speed. So the second part of the sentence is wrong. The total time taken to complete the race and the total distance traveled by the cyclist at her high speed, again at high speed, is wrong. So the total time taken to complete the race and the total distance traveled by the cyclist, that would be the correct answer. Question 3 says the diagram shows a series of images of a moving object taken at regular intervals. So that means equal time intervals between each image. The object is moving from left to right. Which statement describes the motion of the object? So the distances at the first part were equally spaced. So we are moving with constant speed. Then the distance increased in the same time interval. That means that the object is accelerating. So the object accelerates continuously. No, there was constant speed at the start. Decelerates continuously. There was no deceleration. The object travels at constant speed and then accelerates. Yes, so the answer is C. Question 4 says a plastic ball has a mass of 4 grams and a volume of 20 centimeter cubed. There is a crack in the ball's surface. The ball is placed in a bath of water. Water leaks into the ball without changing the volume of the ball, and eventually the ball sinks. The density of water is 1 gram per centimeter cubed. Which mass of water has entered the ball when the top of the ball is first level with the water surface? That means that the density of the ball is equal to the density of the water. So the mass of the ball, which is unknown, divided by the volume of the ball, which is 20, is equal to 1 gram per centimeter cubed. So the mass is equal to 20 grams. And the original mass of the ball was 4 grams, so we subtract 20 minus 4. We get the mass of the water entered the ball, which is 16 grams. So the answer is B. Question 5 says a satellite orbits the Earth at constant speed in a circular orbit. Which statement is correct? The resultant force on the satellite is 0. No, there must be a resultant force, so the direction changes, which means that there is a change in velocity and acceleration. The resultant force on the satellite is towards the Earth. Yes, that is towards the center of the circular path, so the answer is B. Question 6 says the diagrams show 4 identical objects. Each object is acted on by only the forces shown. Which diagram shows an object in equilibrium? So for choice A, we have 20 newtons downwards and 20 newtons upwards. That's a resultant force of 0. But if you take a pivot at this point, these forces cancel out, but the 10 newton would have a clockwise moment. So this is not an equilibrium. As for B, we say that the 10 newton downwards is not balanced by the 20 newtons upwards. So there is a resultant force of 10 newtons upwards. For C, we have the 10 newtons on the sides cancel out, but the 10 newtons upwards is not cancelled by anything at the bottom. So it is not C, so it must be D. Question 7 says a resultant force F accelerates a car of mass m along a straight horizontal road from rest to a speed v in time t, giving it a momentum p. Which pair of relationships for this situation is correct? So pt is equal to mv. mv is equal to the momentum, which is p, so the time here is not correct. The next one, p is equal to mv, that's correct. And f is equal to pt. No, the force is equal to the change in momentum over time, not times time. So ft is equal to p, the force multiplied by time, which is the impulse or the change in momentum, is equal to p, which is the final momentum, minus 0. So this is the correct answer. Question 8 says the diagram shows part of a roller coaster ride with the car at different positions. The car runs freely down from position X to position Y and up the hill on the other side. What happens to the energy in the kinetic store and the gravitational potential store of the car as it moves from X to Y? So that's going down. Going down means gravitational potential energy decreases, and anything that falls down initially starts accelerating, so the kinetic energy increases. So the answer is C. Question 9 says a box is initially at rest at the top of a rough slope. The box slides down the slope and the weight of the box is 20 newtons. The slope is 4 meters long and 2 meters high. The box does 10 joules of work against friction. That's lost energy or wasted energy. as it slides down the slope. What is the speed of the box as it reaches the bottom of the slope? So we can use the equation for conservation of energy. The initial gravitational potential energy plus the initial kinetic energy is equal to the final gravitational potential energy plus the final kinetic energy plus losses or wasted energy. So substituting by the numbers here, mgh for the initial gravitational potential energy, we have mg as 20 by the height 2 plus the original kinetic energy was 0 because it was at rest. The final gravitational potential energy is 0 because there is no height at the bottom. The final kinetic energy, we have half times the mass, which is the weight divided by 9.8 times the speed squared, plus the losses, which was 10 joules. First, we subtract 10, and then we divide by this section to get the velocity squared, and then we square root the velocity. That gives an answer of 5.422 and so on. So we can approximate this to 5.4 meters per second. So the answer is A. Question 10 says an electric car is charged overnight in 8 hours. 180 megajoules of energy is transferred. What is the power of the charger? So power is equal to energy divided by time. So we have the energy 180 times 10 to the power of 6 divided by the time, which is in seconds. So we have 8 hours multiplied by 60 minutes multiplied by 60 seconds. That gives an answer of 6,250. So that's approximately 6.25 times 10 to the power of 3, which is kilowatt. So the ones in megawatts are rejected, and the answer would be A, 6.3. Question 11 says an object is a depth h below the surface of a liquid. The pressure due to the liquid at this depth is P. The gravitational field strength is G. What is the density of the liquid, rho? So if pressure is equal to rho GH, rho would be equal to P divided by GH. So the answer is D. Question 12 says Brownian motion is the random motion of particles. In which states of matter is Brownian motion observed? So they cannot be observed in solids. So any answer with solids would be rejected. So the answer is B, gases and liquids only. Question 13 says the volume of a fixed mass of gas is varied. The temperature remains constant. Which graph shows how the pressure P of the gas varies with the volume? So pressure and volume are inversely proportional, so we would pick a graph of P against 1 over V and a straight line through the origin. So the answer is D. If it was pressure against volume, it would look like this. This is the shape of an inversely proportional graph. So this is in case of the x-axis being volume, not 1 over volume. Question 14 says liquid evaporates from a beaker. What happens to the temperature of the remaining liquid and how does this temperature change affect the rate of evaporation? So when a liquid evaporates, the rest of the liquid has a decreasing temperature and the rate of evaporation decreases as temperature decreases. So the answer is A. Question 15 says thermal energy delta E is supplied to an object of mass m, which does not change its state during the heating process. The temperature of the object rises by delta T. What is the specific heat capacity of the object? So we can use the equation delta E is equal to mc delta T, and we need to calculate C, so we divide by m and delta T. So it's delta E divided by m delta T. So the answer is A. Question 16 says a room is heated by a radiator. The diagrams X and Y show two possible circulations of hot air which heat the room. Which diagram and reason explain the heating of the room by convection? So hot air near the radiator would rise, so it's X, not Y. And is it because air density decreases when air is heated, or air density increases when air is heated? The density actually decreases because the volume increases, so the answer is A. Question 17 says a student writes down some facts about two transverse waves. Wave 1 has a frequency f and a velocity v. Wave 2 has 4 times the frequency and is traveling at a velocity of 2v. What is the wavelength of wave 2 in terms of f and v? So the wavelength is equal to speed divided by the frequency. So the speed is 2v and the frequency is 4f. So that's 2 over 4v over f. 2 over 4 is 1 over 2, so it's half v over f or v over 2f. So the answer is D. Question 18 says straight wave fronts on the surface of a ripple tank approach a gap in a barrier. The diagram shows how the wave fronts change shape as they pass through the gap. What is the name of this effect? That's diffraction, because the waves are spreading. So the answer is A. Question 19 says light travels from air into glass. What is the relationship between the refractive index N of the glass and the angle of incidence I and angle of refraction R? So the refractive index is equal to sine the angle in air divided by sine the angle in the medium, or the other medium, which is glass in here. And since we are moving from air to glass, the incidence would be in the air and the refraction would be in the glass. So it's sine I over sine R. So the answer is C. Question 20 says which diagram shows the image correctly formed by reflection? So we need only lateral inversion, but it is upright. So the tip of the arrow is pointing down, yes, but these should be far apart like in D. So the closer one would have a close distance, the far one or the far end would have a far end in the image. So the answer is D. Question 21 says a student passes parallel rays of light through 4 different converging lenses. He measures the distance x and the distance y for each experiment. Which lens has the longest focal length? So x is not related to the focal length, y is the focal length. So the longer y is, the longer the focal length. So we choose the longest number in y, which is 3.1. So the answer is B. Question 22 says the frequency of a microwave used in a microwave oven is 2400 megahertz. What is the wavelength of these microwaves? So wavelength is equal to speed divided by frequency. So we divide 3 times 10 to the power of 8, which is the speed of light in vacuum or air, divided by 2400. Mega is 10 to the power of 6. And that gives an answer of 0.125 meters. So the answer is A. Question 23 says which row gives typical values of speed of sound in a solid and a gas? So in a solid that would be in thousands, and gas like air that would be hundreds. So the answer is D. Question 24 says a hard magnetic material can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary magnet. Which row shows whether iron and steel are hard or soft? So iron is actually a soft magnetic material and steel is a hard magnetic material. So the answer is C. Question 25 says a power source is connected to a resistor XY. In which direction are the conventional current and the flow of free electrons through the resistor? So through the resistor, the current goes from positive to negative. So it would be from Y to X. And the electrons always flow opposite to the direction of the conventional current. So it would be from X to Y. So the answer is C. Question 26 says which unit is used to measure the electromotive force? An electromotive force is a potential difference or voltage, so the answer is volts. Question 27 says the graph shows current voltage characteristic for a filament lamp. Which statement describes how the resistance of the lamp changes as the voltage increases? So as the voltage increases, it needs more voltage than current. That means that the resistance increases. So it does not decrease to 0. It does not decrease but not to 0. The resistance increases. That is correct. So the answer is C. Question 28 says, in the diagram, rod R is suspended from an insulating thread. When the positively charged rod Q is brought close to rod R moves away, it is repelled. That can only happen when there are like charges on both objects. Which conclusion can be made from this observation? Rod R is charged, but it is not possible to identify. No, it is possible because we already know that Q is positive. Rod R must be positively charged. Yes, it must be positively charged. It is not negatively charged. They would attract. It is not uncharged. They would also attract even if R is uncharged. They still attract due to induction. Question 29 says the circuit diagram shows a circuit used to run a DC motor from an AC supply. Which graph shows the current in the motor? So if this is the positive terminal and this is negative, the current would go from the top, and it can flow through this diode and go to the motor, or it can go down and then blocked by this diode. So the current would go in the motor downwards. And if we reverse polarity, the current would go from the bottom side. It cannot pass through this diode. It goes up to this diode and again flows downwards in the motor. So if you reverse the polarity of the supply, still the motor works. That is like a full wave rectifier circuit or a bridge circuit. So it would be like the diagram in D. Question 30 says the circuit shown can be completed by inserting components at X and at Y. The completed circuit is a potential divider in which the potential difference across component Y increases when the temperature increases. So when temperature increases, we need a thermistor, and the thermistor resistance would decrease, so the voltage across the thermistor would decrease. but we need the voltage across Y to increase. So the thermistor would be at X and there will be a resistor at Y. So light dependent resistor is rejected at X, resistor is rejected at X. We need a thermistor at X and a resistor at Y. So the answer is D. Question 31 says a piece of soft iron XY has a coil of wire wound around it. The end pole of a bar magnet is pulled away from end X, which causes an induced current in the coil. This current would oppose the motion of the magnet. So if there is an end pole moving away, this would induce an S pole here to attract it, to oppose the motion of the magnet. The magnet is now turned around so that the end pole is on the left. It is taken to the other end of the soft iron and the end pole is pushed towards the end Y. So this is the new position of the magnet with the end pole at this point moving towards the coil. So the current in the coil would oppose the motion of the magnet. Now the magnet approaches. Now we need to repel it. So an end pole would be induced on this side. On the first situation, there would be an end pole here, and now there is an end pole here, so it would be the same direction of current. So now, which statement is correct? The new induced current is in the opposite direction, no. Opposite direction, no. Same direction, yes. And causes the soft iron to attract the end pole? No, it is repelling the end pole because the end pole is moving towards the coil, so we need to repel it as a reaction. That is Lenz's law. So the answer is D. Question 32 says the diagram shows a wire in the magnetic field between the two poles of a magnet. The current in the wire rapidly changes between a constant value in one direction and a constant value in the opposite direction as shown in the graph. So what is the effect on the wire? So the poles are the same and the magnetic field direction is the same, only the current is reversing, so the force would be also reversing. So the choices are the force on the wire alternates between one direction and the opposite direction. That is a correct sentence, so the answer is A. Question 33 says a transformer has NP turns on its primary coil and NS turns on the secondary coil. The voltage across the primary coil is VP and the voltage across the secondary coil is VS. What is the relationship between these four quantities? So the ratio between VP to VS is equal to NP to NS. So the answer is B. The ratio of VP over VS is equal to NP over NS. Question 34 says a magnesium ion has a double positive charge and the chloride ion has a single negative charge. Which statement is correct? A chlorine atom gains an electron to form the chloride ion. That is correct. Gaining one electron causes a single negative charge, so the answer is A. Question 35 says which row correctly describes an example of a radioactive decay. So a stable nucleus would not emit anything, so it is not A. Unstable, 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 yes. So alpha, alpha or beta. Alpha and beta radiation cause a change of element because the proton number changes. For alpha particles it is decreased by 2, in beta particles it is increased by 1. So no change of the element is rejected, so the answer is B. The element changes. Question 36 says a radioactive isotope of sodium has a half-life of 15 hours. The table gives data from an experiment to show how the rate of decay of the isotope varies with time. The background count rate has not been subtracted from these data. What is the background radiation count rate? So if we take the final time, so that's the total time of the experiment, 30, and we divide it by the half-life, we get 2 half-lives. That means that we divide by 2 times. That's a total of dividing by 4 from the initial value. But the initial value included background. So if we remove the background from the 400 and then we divide by 4, we reach the final activity. But in the table, the final activity also includes background. So this means that this calculation is equal to 115 minus the background, without background. So if you multiply by 4 on the other side, we have 400 minus the background is equal to 460 minus 4 times the background. So if we move this part with a positive sign on the other side and this to this side, we have 3 times the background on the left side is equal to 60 on the right side. So the background is 60 divided by 3, which gives an answer of 20 counts per second. So the answer is C. Question 37 says what happens in the process of nuclear fission? Is it electrons are added to a nucleus, electrons are removed from nucleus? No. So A and B are rejected. The nucleus of an atom splits. That's in fission, yes. So the answer is C. Question 38 says the time taken for the Earth to orbit the Sun is approximately 365 days. The average radius of the Earth's orbit around the Sun is 1.5 times 10 to the power of 8 kilometers. What is the average orbital speed of the Earth in meters per second? So we divide the circumference of the orbit, which is 2 pi r. So 2 pi times 1.5 times 10 to the power of 8, but that's in kilometers. So we need to multiply by 10 to the power of 3. Then we divide by the time in seconds. So 365 days multiplied by 24 hours multiplied by 60 minutes and 60 seconds. That gives an answer of 29,885.775, which we can approximate to 3.0 times 10 to the power of 4. So the answer is C. Question 39 says the Sun transfers energy to the Earth through electromagnetic radiation. What are two of the parts of electromagnetic spectrum to which most of the energy belongs? So most of the energy emitted from the Sun is in the range of infrared, visible light, and ultraviolet. So it's not gamma and X. It is visible light and infrared. Yes. Microwaves, no. Microwaves, no. So the answer is B. Question 40 says, how does the Sun produce its energy? It is by fission, no, it's fusion. Of helium or hydrogen, it's of hydrogen into helium. So the answer is D. So this was the end of the exam. I hope you enjoyed this video. Keep practicing and I will see you in another video.